The Daily Exchange. We're here with Patrick from Hedera Hashgraph, and we're talking about the new Bitcoin Cash fork and the Bitcoin prices, guys. We'll see you guys right after this. Guys, welcome back. We're here with Patrick from Hedera Hashgraph. Welcome to Daily Exchange, Patrick.
Thanks, Frank. Thank you for having me. Appreciate it.
We're doing a couple of just trading updates right now. Bitcoin, there's a bit of movement in the market, Patrick, and then we'll get straight into having a chat with you. But right now, Bitcoin is changing hands around $6,438 right now, which is really interesting. Bit of a comparison right now we've got between the top 20 currencies that are out there. You know, everyone talks about currencies, Patrick, and you know it's super volatile. But apparently right now, Joel, if you've got this graph, that Bitcoin is more stable than most of the other currencies that exist out there, which is kind of interesting over the last 2 months. Been a massive, obviously, form of grief. People are wondering about, you know, with the liquidity of Bitcoin, but obviously that volatility potentially could be a little more stable. I think the Turkish lira has been quite brutal. Brazilian real and the Argentinian peso looks pretty gnarly.
Agreed. Surprising.
Very surprising. Ethereum, bit of news update there, guys. $212 currently changing hands. Now, there's been a bit of a big deal. The SEC has come out and brought some charges against Zachary Coburn, the founder of EtherDelta. A massive issue here because some of the ERC20 tokens that were traded on the exchange have been classified as securities. I believe Nexo might have been one of those, and there's a whole series of different bits and pieces there. Kind of scary. They've settled the actual matter for $390,000 in fees and charges, but it does get to show you that the SEC is going to probably come out with some teeth fairly soon. Bitcoin Cash, now the update on the fork right now, there are two coins apparently now changing hands on Poloniex. Goldman Sachs actually is backing Poloniex, by the way, and the two coins are BCH-ABC and BCH-SV. Both these coins, its price potentially between BCH and, sorry, ABC, I'm just going to call it ABC and SV because it's too hard to say. But apparently, ABC is 4 times higher than SV right now, pitching that potentially ABC is going to be the fork that wins and SV is not. It is obviously quite a controversial thing to have multiple strains of Bitcoin Cash right now trading. BCH, SV, what's that, 115 versus 465?
I mean, this is a fork of a fork. So, what can I say?
What the fork?
Exactly.
Couldn't resist. All right, guys, let's launch into talking with Patrick. Patrick, you are the Senior Vice President of Products at Hedera Hashgraph.
Yep.
Obviously, the parent company of Hashgraph is Swirls.
Not the parent.
Sorry.
Not the parent.
Not the parent.
Nope, but we can get into that.
Not of Hashgraph, sorry.
Yep.
And then we've got, you obviously have been in the distributed technology business for over 20 years now, so lots of experience.
Yep.
Just want to explain a few key things before we get on because this is very important. The first is to know that Hashgraph is not a blockchain.
Absolutely correct. Yes.
Hashgraph uses unique architecture for its consensus, so it's very, very unique in that way.
Yep.
It does have a few technologies from blockchain tech, and is also referred to as a distributed ledger technology.
Yep.
Some people like to compare Hashgraph to a directed acrylic graph, a DAG for short.
Yes.
Which is very important.
Yep.
Like Nano or IOTA, that's more what Hashgraph is like. But again, Hashgraph is its own thing, it's separate.
Yes.
Furthermore, as we're going to talk about this, Hedera Hashgraph is the public available version of the Hashgraph software. And there are obviously private versions of Hashgraph that also exist as well.
Yes.
So
Correct.
Hedera Hashgraph is the public DLT or the...
Yep, so let me explain it. So Swirls is a company that owns the sort of IP for Hashgraph. Swirls has licensed that Hashgraph technology to Hedera. Hedera is, and that license is available for now for Hedera to build a public DLT using Hashgraph, and they're the one company that's going to be allowed to do that. So I'm with Hedera, and we're building a public DLT on Hashgraph.
Now, Joel, we've got a quick image, Patrick, for you to bring up which is Hashgraph versus a blockchain, because I want everyone to understand this is really, really important. So we've got the blockchain on the left here,
yep,
and we've got Hashgraph on the right. Can you sort of take us through a little bit of this,
sure,
Patrick?
So
I know these diagrams look insanely complicated, but let's try and break it down for everyone.
We wrote these diagrams, and they're still complicated. So think of I think of Hashgraph. I'm going to back it up a little bit. Hashgraph to me was I've been involved in, as you said, distributed computing 20 years. It was back 3 years ago I got introduced to Hashgraph when Lehman Baird, the inventor, essentially said, oh, I think I might have solved something I didn't think could be solved, which was to basically enable a distributed consensus algorithm that was really fast, really fair, but still very secure, and as secure as it can get, actually, and we can cover that later. So he basically sort of was solving this completely independently of all of the other things going on in the crypto industry and around Bitcoin and stuff like that. So he didn't start with this notion of trying to make a better blockchain. He started with the notion of, all right, how can I enable communities of users, and maybe it might be online games, to basically come together and be able to trust each other in an ad hoc way without necessarily having to have centralized services. All right. He basically, spent a few months thinking about it and figured, all right, this is impossible. Then he'd go off and spend a few months thinking about it again, and it was impossible. And essentially, he had a breakthrough in sort of the mid-2015 timeframe, and it was essentially a mechanism where he used a directed acyclic graph as a mechanism to distribute, gossip all the nodes out information about what they know about a transaction, such that at a certain point in time, every node sort of understands what every other node knows about those events and transactions, such that they can vote on them themselves. And that's called virtual voting. And the result of that was that, hey, each of them basically can come to consensus on the order of transactions and the time those transactions actually occurred. So it's a very, very novel. So
that's why in that graph, if we could just go back to it for a sec, Joel, you've got on the right there, we've got, this is the gossip mechanism that's making its way
exactly.
through.
That's just they're literally the transactions in the state machine flowing through the network. Blockchain's different in that for the trust of blockchain to work, you actually have to have a record of every single transaction kept in the chain in perpetuity, because they're all tied together cryptographically, and if you were to break any one of those things in the chain, the trust model breaks. So it's something that continues to grow over time, never gets shorter except when different forks of the chain disappear based on the proof of work models and stuff like that, but that chain gets bigger. Hashgraph is different in that it's just a state machine. At any point in time, there's a representative state of the transactions at that point in time, and you can know that you can trust that essentially they've reached consensus on that point in time as well.
Okay, let's talk about what are the three key differences between Hashgraph and a blockchain?
Sure. It's faster, all right, in that we basically know that we can get up to hundreds of thousands of TPS, transactions per second if necessary. It's more secure in that it can reach finality on consensus, so that you can know at any point in time that consensus has been reached with finality. You can't do that necessarily very well. Certainly proof of work blockchains. There are other blockchains that can do that, but the proof of work ones can't. And then lastly, it's fair, so that you actually know that the transactions are in the order they were received, all right, and they haven't been manipulated in any way. When you have leader-based systems, distributed consensus systems, the leader, such as the miner, can choose to throw some transactions away or adjust the order of the transactions within a block, and they can control when that happens, basically, and how that happens. So you can't necessarily build things like auctions or markets with that technology as effectively as you can with Hashgraph.
Wonderful. And okay, so Hashgraph is obviously a privately owned technology. Obviously, it's slightly different to a blockchain in that senses.
Yep.
And obviously there are many things that Hashgraph can do that a blockchain just can't do as well, which is awesome. Tell us, what are some of those things, I guess, that Hashgraph can do that a blockchain cannot do, as an example?
So if you back it up, so Hashgraph is the consensus algorithm. All right, we're going to take Hashgraph and build a public DLT with it. All right, and that public DLT is going to be something that's open to everybody to use. All right, you don't have to talk to Hedera to use the network, to build apps on the network or anything like that. And eventually you won't have to talk to Hedera to run a node on the network and be paid for running a node on the network. All of that will be wide open. So it'll be a open public DLT network that's going to support a cryptocurrency, a smart contract service, and a file storage service eventually. So with the speed and the security and the fairness properties we have, we think we can do things like micropayments, where we can basically transfer value of a penny or less for at speeds that can't be handled today, and with fees that are a hundredth or a thousandth of a penny, essentially, something like that.
Wow.
So it just opens up use cases that people have talked about wanting to do on Ethereum and on Bitcoin, but sort of those technologies just haven't been able to handle it for a myriad of different reasons.
Yeah, it's very prohibitive. The transaction costs, the consensus fees, things like that.
Fees are higher, transaction throughput's lower, just a mixture of things.
Yep. And just quickly, I think it's because everyone, we're just trying to get this, just lay this foundation before we launch into this, is just Swirls and Hedera. What are the difference?
Sure.
What's the difference there?
I said it, I kind of mentioned it up front. So Swirls owns the IP for Hashgraph. Swirls has licensed that IP to Hedera. All right. So Hedera is the sole, the sole licensor of Hashgraph for building a public DLT. Okay, nobody else can do this. One of the reasons we're doing it actually is to prevent forking, funnily enough, given the conversation we had forking just earlier in the show. The reason for that is that Hedera, we're really designing it to be enterprise grade. There aren't many public DLTs out there that enterprises and companies are building mission critical applications on today. And there's we've talked to enough companies to know there's a mixture of reasons they're not comfortable with that. One is the governance structure of some of these networks. The other is the stability of those networks. Sometimes it's the security of those networks. Sometimes it's the performance of those networks. So the license for Hashgraph and the fact that it's IP protected is there really to allow organizations to be able to trust there's only going to be one version of Hedera, and it's not going to fork, essentially, so there's going to be two at some point in time, and now I've invested millions of dollars building applications on Hedera, and now there's suddenly two. Now what do I do, essentially? So that's the goal. Now Hedera itself, it's not owned by Swirls or anything like that.
Yes.
Okay, it's actually an LLC in the US, so it's an LLC. It's going to have 39 organizations that are going to act as the governing council that we can talk about later.
Yes.
But they are all part owners of Hedera. They don't have any financial gain from being an owner. It's not like they get to be, they're not paid profits or dividends or anything like that. And also, that ownership structure is term limited. They can only be an owner for 3 years.
Right.
And they can get voted in to have another 3 years of membership, but they can't serve any more than 2 consecutive terms.
Right.
So it's going to revolve over time. So the goal there really is to ensure we have, a wide distribution of different parties participating in helping govern the network, with no single owner or single controller, and keep it. They're bought into the fact that they want to keep the network growing and stable and secure, and they all, everybody's got incentive alignment to do the right thing.
Awesome. Okay, and then, so there's a native cryptocurrency on Hedera.
Yep.
Tell us about what's that used for?
Sure. So, so Hashgraph is a consensus algorithm. All right. When you basically are now going to apply that and use it as a public DLT, you have a bunch of nodes on the network, all right, that are going to gossip and achieve consensus on different transactions, on a ledger. Any public DLT that's open, that's going to allow any node to join and be a node on the network, has to protect against something called a Sybil attack, which is where if I have 100 nodes sitting on the network and a botnet gets stood up, all right, and creates 300 nodes just completely randomly, they can disrupt the network because they basically suddenly have all the voting power if all votes are equal to 1. Hedera actually uses a proof of stake model where each vote of a node is tied to the amount of stake. It's weighted to how much stake that node has in their account, so that the currency, it means that for a successful Sybil attack to occur, I've got to have now more than 1/3 of the stake on the network, not of the nodes. And our goal is that with the currency, it becomes widely distributed, high in value, such that for someone to try and buy 1/3 of the stake of the currency, it becomes very difficult to do that.
Yes.
Okay. So that was the original goal.
So nodes stake Hedera coin, so
yes.
which is H
bar.
H bar.
Yes. So each node will basically stake.
How much?
Good question. So not sure yet. I mean, but it'll basically be as much of the currency that's out there, essentially, in the industry. Now, the other thing that we're doing that's a little different to what others are doing is that we're allowing account holders who don't necessarily have a node, aren't running a node, to proxy their stake to a node. So that node now has its stake plus all the stake of the account holders that have proxied their stake to it. And that node now gets bigger node payments because they've got more stake proxied to it.
So other account holders can stake with them.
Yes, and then basically that node will pay the account holders who proxied to it, rewards. Yeah. They get a node payment coming in, and they'll take that node payment and pay, all the people that proxied to them.
Yep.
So it's a way of getting value out of your HBAR currency without necessarily having to run a node and not having really to do anything, essentially. And our goal is that we get as much of the stake, much of the currency being staked to nodes as possible. We want the more of it because it keeps the network secure.
Yep, makes sense. So you've got, let's talk about the virtual voting model to reach consensus. How does that work? And I guess how is that different from delegated proof of stake?
Sure. So if you look at, I'm going to back off from delegated proof of stake and just talk about virtual voting. Yep. So there are a number of ways you can do distributed consensus. All right. There are leader-based systems that emerged in the 80s and 90s and that were implemented by database systems and things like Raft and PBFT and stuff like that. They were implemented in a database and they're used by things like Hyperledger and stuff like that. So you've got those leader-based systems. You also have proof of work that was Satoshi came up with, which was completely novel and I think just is groundbreaking and what it's basically driven in terms of all the innovation that's happened since then. Yes. Is amazing. You then have sort of economy-based systems that used different economic drivers, a little like DPoS, delegated proof of stake. Yes. There's different drivers on how you might elect leaders and stuff like that. Yes. Okay, so all of those are interesting. Leader-based stuff doesn't work well in public networks because you can DDoS the leader and take them offline. Right. Proof of work obviously has the issues that it's not a very green technology, to say the least. The economy-based systems end up having to deal with all of the fundamental issues you have with chaotic markets. Yes. All right, look what's happened with EOS now, given what was perceived to be a fairly, everybody wanted to do the right thing, but just what's happened in the way that the DPoS model in EOS now has emerged with centralization of, and voting blocks and cartels and stuff like that. So you can't model that very efficiently. All the way back in the 70s, there were basically some consensus algorithms created called voting algorithms that were proven to be very secure, provably secure, highly available, very hard to DDoS, if impossible to DDoS. They were fantastic algorithms, all right, but completely unimplementable because the amount of network traffic that they generated overwhelmed the network. I mean, basically, my vote goes to all the nodes, and they acknowledge that vote back to me, and then I acknowledge that I got their acknowledgement, and you do that multiple times, and it just completely overwhelms the network. So that
N cubed.
Exactly. Yeah. It was like just fantastic theory, totally unimplementable. Yeah. So that stuff has lived there, for 40, 50 years. what Lehman did was essentially he basically leveraged the gossip about gossip in terms of sharing metadata across all those nodes, such that each node knew what every other node knew, and could essentially take those voting algorithms were invented in the 70s and virtually vote, because it could just know, if I know everything, if node A knows everything node B knows, and node B knows everything node A knows, I can just run the voting structure that node B would do, and I know the way they're going to vote.
Yep.
And that's the virtual voting, and that's what makes it very, very efficient, essentially, and secure.
Right. So
I know that was like, I suggest people go watch Lehman's
no, 100%.
YouTube videos on this, because he does a far better job than I do at explaining this. So
no, I think it's crucial, regardless of anything, that we have a clear understanding. I think what's everyone who's watching, in our community here as well, is that there is a distinct difference.
Absolutely, yes.
And I think that's what's really important. Yep. And I just want to really shine that out and ensure that everyone understands and knows that. I think that's a fundamental thing.
Yeah, absolutely.
And I think, if you were to boil that down, I think there is, we can get into the technicalities, but I think, in the high level sense, what I'm hearing is that we have a unique way where nodes can talk to each other, and they can virtually vote on something, on a particular item,
on transactions,
on transactions, and each of them independently eventually will know what that other person has done and is doing, and therefore reach consensus.
Yes, exactly. So everybody knows that the order of the transactions they were received and the timestamps for those transactions, and everybody has the same view of that.
Okay.
Basically.
And this is this gossip about gossip. Did you want to give us a quick high level, because that specific part of, you said node A and node B know what each other knows?
Yes.
So just give us a little high level on that.
So literally the gossip about the gossip they're gossiping, all right, is literally information. So if I'm a node and gossip protocols are used by most DLTs out there. It's a way of very quickly disseminating information to large numbers of nodes, all right? And it's about what information you include. So each transaction needs to be shared with all the nodes, so every node in the network knows about each transaction. But what we add to it is a couple of bytes of information about who gossiped that transaction to me and when, such that with that extra piece of information, a couple of pieces of information, which is the gossip about the gossip, it allows each node to establish a picture of when every node received those transactions effectively across the network, and then can vote on it, essentially. So that's really all we're talking about, a couple of extra bytes of information.
Wonderful. And then I guess, with that, I guess mechanism in and of itself, which is I guess unique to Hashgraph. I guess what happens if there's a bad transaction? Like, how does that sort of get found out in the
Sure. So
if someone tries to put in something sketchy or something.
Exactly. So essentially, we will protect against, as long as less than a third of the nodes are not bad actors. Yeah. Okay. The network will ignore people trying to drive in, fake bad transactions. Right. Essentially, it will receive, 2/3 of the network will achieve consensus on the good transactions and ignore the bad ones. So that's why it's that, that 1/3 property that's so critical to us. Yeah. That as long as, more than 2/3 of the network are good actors, everything's good. As soon as we hit that third problem, then we have a problem. Basically. But it'll just basically, the protocol just deals with it. It'll throw them away, it'll ignore them. Wonderful. It just, it'll just handle it.
Awesome. And okay, let's move on. So let's talk about traditional, the blockchain. We talked about it on the show before with the trilemma between decentralization, security, and scalability. They sort of sit on this triangle. George Salmon came on and had a great explanation about that. Tell us, where does Hedera Hashgraph sit with that?
Look, so that trilemma thing, basically initially talked about by Vitalik. Really, I mean, if you think about it, it came from it's all about where you sit and what you're looking at and your view of the world. And the view of the world that they have is blockchain and proof of work. So a lot of it is basically, it's through that lens they look at that trilemma. So if I look at that trilemma, I look at it and say, all right, Performance. Okay, we think we can get to hundreds of thousands of TPS. I don't think we have a performance problem, all right, as compared to other things. If you look at security, all right, we are ABFT, essentially, which is the gold standard for distributed consensus security, essentially.
So blockchain fault tolerance?
Yes, no, Byzantine fault tolerance.
Oh, sorry, Byzantine fault tolerance.
Asynchronous Byzantine fault tolerant. Yeah. So those basically are both provided by sort of the Hashgraph algorithm itself. Then the last one is centralization, which is always a fun topic because it's such a subjective concept.
Sure.
If you look at this purely from a consensus standpoint, we're basically going to allow thousands of nodes to basically participate on the network and be rewarded for being nodes. So it's highly decentralized from a node standpoint. People also look at decentralization from a governance standpoint. Who can make decisions about what happens on the network? If you talk to someone, if you've ever listened to Rubini, who's the economist in the US, happily just like nailing all of the current public DLT technologies as, hopelessly centralized.
Yes.
I mean, there's just, you can make different arguments there. From our perspective, we look at the government council we have, the fact that we have 39 organizations who are going to help govern the council, that those 39 organizations are going to come from all sorts of different geographies around the world. Mm-hmm. They're going to come from all sorts of different industries, and that they're time limited in the time they can be responsible for it.
So just want to step in here because for a sec. So just to separate this, because I think it's really important with this decentralization piece, particularly the governance and the consensus are separate.
Yes,
and I think that's a very important point.
Yep.
Now, with the governance itself, we're talking about the
council.
The council.
Yep.
And maybe we can dig into that. So who are these people and you were talking about,
yep.
and how are you going about choosing them?
So we're looking for organizations that are very large, 10 billion market cap and more, that are leaders in their industry, that have brand name recognition around the world, that people, when they look at them and hear those names, will generally trust them. As brands. The reason we're going for large organizations is that we are going to give them the ability to control and govern the network. And with that comes a responsibility that they're going to do the right thing. Okay? If we were to allow smaller companies, mid-sized companies, the value of the currency we're talking about here could actually lead them to do the wrong thing because there's so much money involved that their brand's not as important to them, or it's more than their revenue right now. So our belief is these large companies are getting involved because it's not going to be worth it to them to try and influence things on Hedera because it's going to impact their revenues and their reputation and their brand. Okay. Now our belief is they're going to be building applications on the network, so they're going to be users of it as well. So it doesn't make sense for them to impact their brand when they're going to be using the network as well and want to control it. Now, as I said, there's no monetary value they get out of this any more or less than any other organization operating a node or any developer or client leveraging the network. Basically, they're not being paid separately. They can't pay themselves dividends or profits or anything like that. They can't manipulate that way. And again, it's term limited. So after 3 to 5 years, they're out. Somebody else is in. So if they're going to continue using the network, they better leave it in a good place because they want to continue to use it for the next organization to come in and be a governing council member.
And so I just want to clarify this. So because governance and consensus is separate. Completely separate. I hate to say it, but I just wanted to put it out there. 21 block producers with EOS is very different here because the nodes are separate.
Yes.
And whereas the governing council is about the governance and the management of the actual public blockchain itself.
Yes.
So very, very different.
Yes. And so here's where it gets interesting. All right. Nothing's ever perfect. We have to bootstrap. All right. We've got to start and bootstrap a network with nodes running, a governing council governing it, and get tokens distributed out into the world and highly distributed in a way that isn't going to be compromised or attacked and stuff like that. So we're being very, very careful very conservative about how we do that. So initially, the governing council members are going to be running the initial nodes. Okay, that's going to be there for a certain period of time until we get comfortable that we've got enough currency out there that's being staked to the network, that the network is mature and fairly stable before we open it up to allow more people to run nodes.
Right.
So it's going to start, I would say, in a somewhat slightly permissioned way, but we're going to basically allow more and more nodes to eventually thousands of nodes over time, but with the same governing council.
Right.
Limited.
So it's kind of starting bootstrapping in a slightly more centralized way, but then over time,
yes,
it will obviously
yes,
depart from that.
Yep.
And then in terms of that, those council members, will they so they don't get monetary rewards, or
nope.
just how do they get rewarded? I guess to act, be good actors.
Well, they're not doing it out of the goodness of their own heart. Let's say that. And trust me, if this isn't this is harder than the technology. Let's say that, to basically talk to get organizations to jump in, and we're pre-product. I mean, I can talk about it later. We only got the test nets up and running a few weeks ago to Hedera 18. But they're looking at it as a way to basically be at the coalface of a new and emerging public DLT that's being built from the ground up to be enterprise grade, to meet all of the regulatory requirements that they're aware of. And we're working with the SEC and stuff like that. So they're very excited that they get a chance to be there at the table at the foundation of something, and they get brand recognition and reputation advantages for that. Now, obviously, they're all in it to make a buck. So some of them are saying, hey, we can basically provide services to all of the dApps and applications that are going to eventually build on the network. They might think that eventually they will be running nodes that are going to make revenue for them eventually. It's the brand recognition and the reputation of being involved in public DLT, because they a lot of organizations saying, what are you doing about blockchain? So this gives them a story. They're going to be building applications on the network. I mean, they haven't had a public DLT they can use. Now they can basically help govern and control one that they're basically going to build applications on themselves. So a lot of them are talking about building apps on this as well. So it's a mixture of things.
So just to clarify, so the network fees, so fees that are paid for transactions on the blockchain,
yes,
are paid to. Can you just talk us through, I guess,
the fee structure.
Model of the fee structure? Yeah.
Absolutely, yes. So I talked about, you asked me about the currency right up the front. And the foundational reason for the currency is obviously part of the security and safety of the network as a proof of stake model. The other reason for having the currency is to essentially reward the nodes for doing work on the network. I struggle to understand why anybody would want to run and operate a node at tens of thousands of dollars a year or more and not be rewarded for it. Okay, so we think it's appropriate that nodes should be rewarded for contributing bandwidth and CPU and memory and disk for the network to work. So how do the nodes get paid? The nodes get paid by the applications that are using the network. All right, much like you would pay AWS. All right, to basically run your app on AWS, you're going to a developer's going to pay Hedera to basically do crypto transfer, or to store a file for some period of time, or to upload and run a smart contract. Things like that. So the fees are paid by the applications and themselves. Those fees go to Hedera, all right, and then Hedera pays the nodes on a daily basis for the work they've done. Now, there's a question that always comes up to say, all right, why don't why does Hedera, the treasury in Hedera, basically distribute the node, the payments out to the nodes? Why don't the clients pay the nodes directly? All right. So one of the reasons for that is that we're not a leader-based system. All right. When a transaction is submitted to the network, every node in the network participates in consensus. Every node does some work for that transaction. So every node should be rewarded a little bit for helping to achieve consensus on that transaction. We also think it's only fair that if a node can, joins the network and leaves the network within 5 minutes, should they be paid for all the transactions during that day? Probably not. If their stake changes throughout the day, how do you determine how much you should do it, essentially? So we had two models. We could either say, all right, when a transaction comes in and the client pays the fees, we are immediately going to split up that fee and pay everybody at once, all right? Or we're going to take that fee, collect it, and decide on a daily basis, has the node been there for the day? How much stake did they have? And we can then work out the node payment that way. In the first case, trying to do it on every single transaction, we would overwhelm the network.
Yeah.
Because if you had 100,000 accounts that were proxy staking to the network and all deserve a little bit of a payment, that means for one transaction that comes in, we'd have to make 100,000 payments. Yeah. All right, and if we're at 100,000 TPS, that's 10 billion payments we'd have to do
every second.
Every second. Yeah. It just doesn't work. So that's why we've basically said, all right, it's fairer to have, and it's going to be visible to people. It's not like we're hiding this. You'll know that if you're a node for the day, based on how much stake you have, you get a payment daily, basically. Cool. Does that make sense?
Yeah, totally. And so people who use the app, they would either stake.
Yeah, so I could, in my wallet, we're presuming that wallets will basically allow you by default to stake to a node, and you will receive on a daily basis a certain amount of currency back.
Yep.
All right, because you staked to it.
Makes sense. And then the dApps themselves, how do they pay the network?
So they include in each API request to the network, they're basically going to include a fee that they're willing to pay. Okay, and the network is going to basically, debit it from their account and credit it to the treasury.
Makes sense.
Essentially. One thing we're doing though is a little different. When we talked about smart contracts, we're actually using Solidity. We're going to support Solidity out of the gate.
Right.
One of the reasons for that was because we just wanted to essentially support the one ecosystem of smart contract developers that exists.
Yes.
So there's not many others. We will support another smart contract language in the future, but we're going to come out of the gate with Solidity. One of the things we heard about that people have an issue with Solidity and Ethereum is that it's variable pricing. You basically can choose to pay more if you want your transaction processed faster than anybody else's. So therefore it makes it very, very difficult to understand, well, how much should I pay to guarantee some sort of response in return? We're eliminating that and just basically saying, look, the fee structure is going to be, for the smart contract piece of this, it's just going to be based on how complex your smart contract is. And we will determine what that costs, you pay us, and we'll basically process them in the order we receive them and just take out a lot of the ambiguity.
Makes sense. And as a user, so say we wanted to transfer some Hedera between each other.
Yep.
How much does that cost?
So we're still working out the fees, but it's going to be very small. I'm thinking this is like 100th or a thousandth of a penny. Something like that.
1,000th of a penny. That's amazing.
Yep.
Okay, and then.
By the way, anybody who says there's no fees, I also don't understand that either, because we're in a bad place on the internet when people made everything free. Look at email. All right, email is free, and look at all the spam and shit that happens with email. So we will always have a minimum payment of some form. You have to pay to use the network to avoid spam.
Makes sense. And let's talk quickly about the transactions per second. What are the I guess what is the real world transactions per second? I guess that's currently happening right now.
Sure. So back in March at our sort of launch event, we talked about some big numbers. Yes. 250,000 TPS, stuff like that. That was based on the testing we did of the consensus algorithm, Hashgraph. All right, and also the fact that Hashgraph needs to do signature processing, so you need GPUs to basically process those signatures faster. So that was sort of at the consensus layer. We've now added a distributed ledger and a file service and a smart contract service on top of this. So obviously that is going to slow things down a little bit because you're adding more work to the equation. When we look at it from a cryptocurrency transfer standpoint, for things like micropayments, we still think we're going to see 100,000 TPS because they are, they are not heavy users of bandwidth. They're not heavy users of file and disk and RAM, so very lightweight. We won't see those numbers for file storage and smart contract. Okay, those numbers will be less. I don't know what those numbers are. We're still in the middle of doing the testing. But we think we can, with the crypto transfer for micropayments, achieve 100,000 TPS on a single shard.
Wow.
Essentially.
Wonderful.
Out the gate.
And then, so talking about scaling, how will Hedera, I guess, scale?
Yeah. So when I talk about 1,000 nodes, obviously that's not going to be 1,000 nodes in one shard.
Sure.
Okay, so because you get the logarithmic issue of all the gossip about gossip flowing out to everybody, and it just starts to overwhelm it. So we're going to start with a single shard of somewhere like, up to 40 or 50 or more. We're not quite certain yet. Nodes.
Right.
All right. We will then, to scale horizontally, start to add shards essentially, and start to support multiple shards. That's we think over a year away. We're still working on some of the things that we need to enable to make that work. Yeah. But eventually, it's only when we get to multi-sharding that we can start to open this up to additional nodes and start to allow more nodes to join. Okay. So that's how we'll scale. We'll scale horizontally that way.
Right. So multiple, shards, or it's almost like threads within a processor, right?
Yep, exactly.
Makes sense.
So we'll sort of stand up a shard here, and then slowly we'll add more shards and sort of scale horizontally that way. Yes. They're all linked together, so they'll all be ABFT across them all, essentially, and they'll all stay in sync. That's the way we'll scale.
Awesome.
But trust me, it's 100,000 TPS for micropayments. That's a lot of traffic.
That's a lot.
That's a lot of transactions.
That's a lot.
If we can get to that, we're winning. So
100%. And what about in your test net? Have you seen a lot of? Have you sort of tested that and cranked it up the?
Yeah. We're comfortable on the crypto transfer stuff. I'm less comfortable yet on the file storage and the smart contracts because we just haven't done enough testing on that stuff yet. And we're sort of living with some of the. We're living with the legacy of the way Solidity works too, because it just functions a certain way, and we've essentially taken that code base and we've basically put it on top of Hashgraph. Makes sense.
Okay, and then so we talked about you talked about this idea of the asynchronous Byzantine fault tolerance.
Yep.
In that, I guess firstly, do you want to just explain, what that is?
Sure.
As best we can.
As best we can, given I'm not a cryptographer like Lehman. Yeah. And again, I'm going to tell people some of Lehman's videos on this stuff are just fantastic. Yes. He's very exciting to watch. ABFT essentially addresses the issue where you don't have to worry about the underlying stability of the network in relation to if messages get delayed or messages get deleted or anything like that. The distributed consensus layer above it will still reach finality on transactions, irrespective of what happens at the network underneath. Right. When things aren't asynchronous, you have to worry about how much time a message is going to take to get through the network, basically. So you do have to worry about network stability at that point.
And that's congestion, right?
It could be congestion, but it more likely it could be attacks, like DDoS attacks or firewalls that start to block traffic arbitrarily or completely, things like that too.
And so why is Hashgraph the only asynchronous Byzantine fault tolerance or ABFT protocol? Why is that?
So honestly, to put it simply, Lehman's one of the smartest people I've ever met, and he came up with something that is unique, and people thought wasn't possible, and not surprisingly, when people do tend to solve things that other people thought weren't possible, it turns out to be quite a simple solution, and people go, "Oh my God, why didn't I think of that?" Yes. And that's kind of what he's done.
Amazing.
So, yeah.
Cool. Okay, let's talk about the market right now in terms of Hashgraph. With Hedera Hashgraph, I guess being public or private. What is the benefit of being a public network versus the closed networks?
So, when we've talked to a lot of organizations, I mean, we still think there's going to be reasons the company's going to want to have private DLTs, and there's a reason Hyperledger exists, stuff like that. But there hasn't been a public DLT in the market that where organizations have felt, I think enterprises have felt, hey, this would make sense for us. All right, they've had issues with the others, like performance I mentioned, or security, stability, stuff like that. We think we're addressing a lot of those concerns they've had that would allow them to be comfortable to start to use a public DLT, essentially. Now, there could be certain use cases.
And is this like the intranet versus internet whole argument?
Absolutely, right. Yes. Or another would be public cloud versus private cloud. That's probably a better example.
Yes.
I mean, there was organizations there, there's no way I'm moving to AWS because I can't trust it, it's not secure enough, stuff like that. I'm going to have my private cloud and run them ourselves.
Yes.
You know, it took probably 10 years for everybody to realize, well, it isn't quite as cost effective for me to run my private cloud. AWS is doing it much cheaper with economies of scale that I can never get by running my own versions privately. I think the same sort of thing is going to happen with public DLTs.
Awesome. And I guess, you know, in the future, where do you think private and public networks are going to go? Private and public, I guess, blockchains are going to go?
So I think there's going to be, there are going to be cases. So I think we're going to start to see hybrid models emerging, where public DLTs might be used to, you know, transfer value between information that's on private DLTs, as an example. There are certain things about private DLTs today that make sense in relation to privacy and regulations. As the regulations start to change, maybe people start to get more comfortable with public DLTs. So, I mean, I think it's a mixture of evidence. They're going to live together for a while, much like private clouds did with public clouds, and, you know, we'll see it, you know, slowly shift over time.
Okay.
But the economies of scale are just, you can't get it when you're running it yourself.
Makes sense.
So, it just doesn't make sense.
Tell us, let's get into the applications and products that are being built on Hedera Hashgraph right now. You guys had a big hackathon last month, which is awesome. You know, what kind of products are being built on Hedera Hashgraph?
Sure. So we did. So it's, you know, we are a horizontal platform. So we're not sort of like, say, a Ripple or a Stello that we're basically focusing on banks or anything like that. We're a little like, you know, Ethereum in that case, where we're basically happy to, you know, for all sorts of different applications to be built on us. So we're not targeting any specific market or anything like that. Hence, we see lots of different types of applications, people talking about us on it, sort of the obvious supply chain stuff and the provenance of stuff, you know, provenance of information on supply chains. We, you know, payments applications, gosh, you know, gaming-oriented applications. You know, so there's an example of application in Ireland that's saying, hey, we're building a, what is it called? A trivia game, all right? We're building a trivia game, and we want to make sure that everybody knows that if I answer the trivia questions first on my mobile device and submit it, that I was the first and I can see it first on Hedera Hashgraph, basically. And because we have cryptographic timestamps and it's provable that I submitted my transaction before anybody else did, I win. Don't give it to the other guy, as an example.
Awesome. Or
we've got, you know, micropayment examples where Hero FM, and I'm really excited about this one, this is cool. They're a bunch of musicians that have basically said, sick and tired of these centralized services like Spotify or Apple, basically buying up all of the music content in the world and selling it all under subscription. And they're saying, hey, we're going to have a platform that's going to allow artists to make their content available to consumers directly, and consumers can pay, you know, make a micropayment for listening to a song.
Okay. And would that all be in the base currency, or is there the ability for these new dApp builders to create their own tokens?
So they can create their own tokens. I don't think they're going to need to. I think it's been a function of a lot of froth and noise in the ICO market around ERC20s and stuff like that. So they could, but if they were going to use a smart contract, it's going to be more expensive, because it's more expensive to run a smart contract than it is just to use the native cryptocurrency in Hedera. So it's actually going to be, it would be cheaper for them to actually use the micropayments natively in Hedera. They still get the same value. So yeah, in this case, we think it would make sense to, hey, just have people pay in HBAR, and they can, you know, pay a penny to listen to the song.
Makes sense.
We're seeing the same example with say online content, like blog posts, making a donation to Wikipedia, newspaper articles, things like that, paying a small amount to just read things on an ad hoc basis. without having to give you freaking credit card information or sign up for a business contract and stuff like that.
Makes sense. And then you've got, recently you guys have written about Hedera, a drug development firm, starting to use Hedera. Can you tell us about that and I guess some of the other companies?
Sure. So Hedera are doing it from a supply chain standpoint. Yes. So they're basically using it to sort of track the provenance of sort of the pharmaceutical stuff that gets put into their drugs. So that's a fairly classic case that a lot of people have talked about. We're seeing some interest, saying in sort of some gaming applications. There's a public Australian company, a Monica or something like that, I think they're called, that are working with an accelerator in Hong Kong, and that accelerator is called Helix. And they've said we're going to have an accelerator, and we're only going to take companies that want to build on Hedera. So that's pretty cool. So they're going to be doing that. Some of the gaming type applications we're hearing about is sort of the ability to essentially have in-game digital assets that you can start to auction off separately.
Right.
So basically pulling them out of the silos inside games and actually auctioning them off separately in other places. Using the micropayments directly in the game, things like that. So it's happening as well.
That's really cool.
Yeah.
Are there any dApps that are being built in-house right now?
No, we're focused on the platform. I don't want to compete with all of the developers out there who have all sorts of innovative ideas about what they could build on us, essentially.
And for a dApp developer, I guess it's Hedera's council controlled compared to, I guess, an open source a project, which could be forked and things like that. What's the benefit of a dApp developer building on Hedera Hashgraph?
So look, I think we've had to deal with, we deal with a lot of questions today because we're pre-product. Nobody can actually, use the APIs yet. It was only 3 weeks ago that we gave our first hackathon participants access to the test nets. We're going to see more, more developers starting to access the APIs and build applications. At a certain point, our APIs are going to be public. People can just start building on the platform. They don't have to talk to us. All right, they just got to get some, get some HBAR and build their app and basically just start talking to the network. I think it'll just be a case of performance, security, stability, and it's just going to be there and function almost like dial tone for the internet. It's just going to be there, and people can trust it essentially. And that's what we're hoping.
Awesome. In August, you guys had an interview with VentureBeat. Your colleague Mance Hammond said that the research on Hashgraph developed totally independently of the existence of Bitcoin, which is amazing. So I guess even without Bitcoin, Hashgraph would still exist.
Yes.
Given, I guess, that Hedera Hashgraph exists could it exist without the native currency?
Nope. Because you need the currency for a public DLT to have open nodes, essentially. So you need it to protect against those Sybil attacks and stuff like that. Okay. So the currency was always something that we were going to have to do.
Yes.
And it talked about it from the very beginning. So it's always been in the plan. Yep.
Awesome. I guess the token sale of Hedera has concluded. This is in no way financial advice, by the way, guys, as well. You guys use a SAFT, a simple agreement for future tokens.
Yes.
Which is, an interesting new model, and it changed, I guess, away from that ICO model that we had before, which was quite insane.
Yes.
In that case, I guess, how would you classify?
What did we sell?
Yeah.
So we sold a security. All right. A SAFT is a security. No ambiguity there, and that's why when we sold that security, we did it following the rules and regulations of the SEC in terms of selling securities under Reg D to accredited investors only. Yes. And that meant that we weren't, we basically constrained who we could sell the SAFs to accredited investors. We had to KYC them, to verify their identity. We couldn't sell in certain countries. We followed the most rigorous sort of steps in the countries we did sell into to basically determine their identity and make sure that they were accredited and stuff like that. Yes. And again, it's all about ensuring that we have met all of the requirements the SEC would have on us for basically selling those SAFs. Yep. Now, those SAFs aren't tokens. They're an agreement for a future token. At a certain point in the future, okay, we are going to release the tokens to those SAP holders, and at that point, you know, we will be releasing them to them a currency, effectively.
Yes.
All right, and the goal, you know, we don't have any control about what exchanges do and stuff like that. But the expectation, I assume, is that exchanges will say, all right, this is something that we feel like, you know, other people might want to buy, and they'll be able to create an account on our network and allow people to exchange it if necessary.
Wonderful. And then I guess, you know, the mainnet's gone live. HBAR tokens have been created. Mm-hmm. I guess when will they be distributed to investors?
So right now we're in the process of sort of paying. I'll say paying because we have a bunch of developers who are helping test the networks, both on the testnet and the mainnet. We're going to basically be giving them tokens so that they can, you know, test the network and stuff like that, and paying them for doing that. So we're going to start to see some tokens out there with some of that developers in our community. You know, some point next year, you know, likely around in the Q1 timeframe, we'll be opening up access to the network and allowing anybody to start to create an account. At that point, around that time, we'll be looking to release the tokens to the SAF holders.
Right.
Essentially.
So next year. And for traders, are there any exchanges sort of in the pipes?
A few.
Yeah.
Not sure exactly who. Some of those are under NDA right now.
Sure.
But we, you know, we're talking to as many as possible.
Yes.
You know, my preference is that we're focusing on those exchanges that, you know, follow the rules as much as possible. You know, whatever possible in the jurisdiction they're in.
And they would need to be, I guess, would you say that they're going to be a security token exchange, or can it just be a...
This will be any exchanges out there, yeah. Because
Okay.
to us, we are a cryptocurrency in our view.
Yes.
So we're a currency. Not a security token, not a utility token, it's a currency.
Awesome. And I guess zooming out, Patrick, you know, what sort of trends are you sort of seeing in the market right now?
I mean, look, I've been thinking about this for about a year. I mean, a year in crypto world is like 10 years in the rest of the world. It's like in terms of what's happened even in the last year, it's absolutely insane. Who knows what the future holds? I think I'm really hoping that the SEC starts to basically set some, starts to, you know, sort of define or just set some guidelines essentially as to what they're expecting from people. Because I think just the sort of the unknown is what actually is hurting the industry a little bit right now.
Yes.
Because they are doing stuff, but they haven't sort of said what's right as well.
They're kind of just saying what's wrong.
Yes, they're just saying what's wrong.
Yeah.
All right. So you basically, you know, we're in active conversation with them. So we're, you know, that I think that's going to unlock some things. I think going forward, I think people are starting to recognize that blockchain isn't the catch-all for everything.
Yes.
I mean, it was a very buzzy term, and now we're seeing that, you know, maybe people are shifting away from saying blockchain to more like distributed ledger technology instead, which opens up the door to alternate mechanisms like us for doing it, which is great. I think we're going to see some, you know, some other, I'll call us sort of third generation technology emerging too, that is going to push the market even further, which is great. So yeah, I just think there's still lots of innovation to go. I feel like we're in the equivalent of 1994 from an internet standpoint right now. I mean, we're still very, very early in this sort of, you know, ecosystem in this world. So lots to come, I think.
That's awesome.
I don't think we know what this stuff's going to look like in 10 years' time.
And any sort of other projects that you sort of are watching carefully that you sort of, you know, quite important within the space?
So we've been pretty focused on what we're trying to do.
Yeah.
I mean, we basically, you know, keep track of what others are doing, but I'd rather be focused on what do we need to do to basically meet the requirements of the developers we're talking to and the enterprises we're talking to. Yes. And we're going to, you know, focus on our goals and our story and just execute. And I just want to get the network up and running next year, and then, you know, grow it from there. It's going to be exciting.
That's awesome. Lastly, we've been doing a bit of a vignette all throughout, and all our guests on the show, we asked them, it's 12 o'clock this New Year's Eve.
Yep.
And I guess your prediction for the price of Bitcoin, we've had all sorts of different numbers put out there.
Oh, really?
In no way this is financial advice to anyone. This is purely a speculation opinion, but do you have a number in mind for the end of the year?
So look, I've been watching this pretty closely. My view, it's going to stay around $6,000. I don't think anything is going to happen in the industry to basically change that or influence it in any way. Yeah. Based on what I'm seeing, it's pretty stable right now.
Awesome stuff. Guys, we're going to potentially wrap up where we are here right now. And I wanted to thank Patrick for coming on the Daily Exchange and explaining in such intricate detail about Hashgraph. And
I hope this was helpful. So.
It really was. It's an incredible project. And we just thank you so much for driving the industry forward, Patrick. So thank you so much.
Thank you for your time. Really appreciate it.
Excellent.
Doing a good job.
All right, guys. That is Daily Exchange for today. Do subscribe and do follow us. Click the little bell and you'll see incredible guests just like Patrick. And follow us on Twitter. You can follow what Patrick is doing on his Twitter handle as well. It is @Hashgraph or @Hedera Hashgraph, I believe.
Yes.
To find out more information and more details. All right, guys. Thanks very much. It's the Daily Exchange. Yeah!